Welcome back, and let's solve the Leetcode problem. So the Leetcode problem is a minimum time visiting of all points. So on a 2D plane, there's n points with initial coordinate, which is the x and y. We have to return the minimum time in seconds to visit all the points in order to given by points. So we can move the x and y coordinates by following the rules below. So in 1 second, we can move the point vertically by 1 unit, or we can move the horizontally by 1 unit. So moving diagonally with the square root of 2, in other words, like we can move 1 unit vertically and then 1 unit horizontally in 1 second. That means we can move diagonally, we can move vertically, and we can move horizontally. So we have to visit the points in the same area order as they appear in the array. So we are allowed to pass through the points that appear later in the order. So, but these doesn't count as a visit. So if we go through the estimate in here, we are given like a valuation of 3 points, 1, 1, 3, 4, and 1, 0. So to satisfy all the requirements in here, we need to pass through all the numbers. So where do we start initially? By starting the 1, 1 in here. 1, 1 is a blue color in here. Let me mark that with the maybe the green color in here. So this is a 1, 1. And then we need to go through the 3, 4, which is in here. Last but not least, we're gonna need to go to the -1, 0, which is here. Wait, I make a very huge mistake. So originally this is 0, 0, 1, 1, 1, 1 is here. 1, 2, 3, and 4. 1, 2, 3, 4 is here. And then -1 and 0, which is here. So according to the estimate given here, let me copy that explanation. So if we run through it, so the explanation is we go through from 1, 1 originally, which is the starting point, and then we move to the 2, 2. We are moving diagonally, and then 3, 3, and then 3, 4. We're moving vertically, and then 2, 3. Moving back from 3. Okay. Here's the 3, 3, and then 3, 4 is here. That's what we hit for the second point given in here. 3, 4. And then from 3, 4, we're gonna move to 2, 3. That is like from 2 and 3. Okay, moving to here. And then 1, 2. Here it's going to be 0, 1, and then -1, 0. So if we have to count like 1, 2, 3, 4, 5, 6, 7. So that is the reason why we received the total time of 7 seconds in here. That is how it works. Yeah. I think to go through the estimate too, I have drawn something for you guys. Let's consider like 3, 2. Not sure that is going to be easy or not. Okay, we have a 3, 2 originally. So I think we should go through like 3 and 2, which is in here. And then -2, 2, which is here. And okay, that's pretty straightforward. We just need to move horizontally from 3 to, maybe we go next step is a 2, 2. So which is going to be in here. Let me highlight with the red color. 2, 2, and then 1, 2, 0, 2, and then -1, 2, and then -2, 2. So if we have to count like 1, 2, 3, 4, 5. So that is the reason why we received the answer of output of 5 in here. If I am not wrong, that would be the just array problem. So we can simply solve that by using the, let's call like reset. We need to keep track of how many counts we have go through. And then I'm gonna iteration through for all the points. Let's call from 1 to the, okay, let's make the one variable called count. Let's show you the points.count. I want to go through to the count, and then what I want to do is derivative of the x. What I mean by derivative of the x is we're gonna calculate like points of points of index of 0. Detected by the points of index -1 of 0. So technically, I want to have a detection from the this 3 in here minus 1. So that means we are receiving the 2. And then the same for the derivative of y. What we are going to do is point of index. I think that would be the index of 1. So which is going to be the 4 in here because we start our iteration from the 1, and then point of index -1 of 1 is a 4 minus 1. That's going to be the 3 in here. So we receive 3 value like y is 3 and x is 2. So among these, what we can do is we can get the total maybe iteration of the mass of dx and dy. In our case, we're gonna pick up the 3 in here, and the next step we are at the end of the index z, and then we're going to detect like I think we need to round it with the absolute, because if we keep track of the negative in here, it's going to make a awful order because we are using the x and y coordinate. At the end, we just can return the total in here. Let's try to see it. Is that work or not? What did I do wrong? Cannot find the points. Probably that is the typo in here. Okay, let's try. I think the time complexity will be the O of n and space complexity will be the O of 1. That's what I was thinking. Okay, there's another typo. What did I do wrong again? Wait, why I type like a total is a reset? That's weird. Alright, never mind. Yep, if I try to submit through it, the time complexity will be the O of n and space complexity will be the O of n, O of 1, since we don't use any extra space in here. Yep, same time complexity of O n and space complexity will be the O of 1. Yep, and that's pretty much for it, and I'll see you in the next one. Bye!